in this series of videos, I'm going to show how to work on doing problems where we have negated premises. We don't necessarily know what to do with negated premises. Well, we want to use them for an indirect derivation is what we want to do with them. So we'll see some examples of that in these videos. So here we have an argument. The conclusion is negation Q. And we're going to come back and do this as a derivation, but I first want to just see what the argument looks like. So, and we'll come back and make the assumption later. Right now we're just looking at the argument. So the conclusion is negation Q, and there are two premises, one of which is negation of P and Q, and one of which is P. So this tells us, well, it's the negation of a conjunction, right? So what this says is the conjunction is false. So that could mean a couple of different things. It could mean, if it were true, that both P and Q were false, or it can mean that P is true and Q is false, or it can mean that P is false and Q is true. What we can't have is that both P and Q are true. That's what is ruled out by the conjunction being false. Okay, so our second premise tells us, well, wait a minute, P is true though. So you think, well, that means there's only one way then in which the conjunction could be false, namely the other conjunct must be false, right? We have a conjunction, we know two things about it. It's false, but its first conjunct is true, right? So in other words, we know this is true. Sorry, we know this is false, because that's what 2 tells us. But we know this is true. P here, can't select it, not sure why not, but okay, good. So there's P. We know the whole conjunction is false, but P is true. The only way the whole conjunction can be false then is if Q is false, and that's what the conclusion says. So this is a valid argument, but we want to do that in our derivation system. So, as opposed to the derivation system I just did it in English. Okay, so we'll say show the conclusion. We always want to be making assumptions. If we can, a conditional assumption, indirect otherwise. Well, we cannot make a conditional assumption, so we'll make an indirect assumption. And that gives us Q. And now we're going to go ahead and put in our two premises. Okay, so we would now want to look to use our inference rules or to see if we can box and cancel. Well, we cannot box and cancel because we don't have negation Q for direct derivation, and right now we don't have a contradiction, so we can't do ID, and we're not trying to show a conditional, so we can't do CD, so we're going to need to do some inference action. Well, what inferring should we do? Well, we started with this indirect assumption, so probably we want to find a contradiction. So there are three possible contradictions we might go for. We might go for the contradiction with 2, which would be negation Q. We could go for the contradiction with 3, which would be P and Q, or we could go for the contradiction with 4, which would be negation P. Which one of those do we want to go for? Well, probably we want to go for P and Q because we already have P and we have Q, so we can just build P and Q. And that's what we're going to do. We're going to say 2 for a join, and now we have a contradiction between 3 and 5, and our derivation is done. So this illustrates the general strategy of what to do when you have a negated premise. What should you do when you have a negated premise? When you have a negated premise, you want to get the contradiction of it. You want to get the unnegation. You want its unnegation for a contradiction for ID. So that's here we have this, that negated premise. So we want its, so in this case the negated premise is negation of P and Q. And so we saw we want its unnegation. That's just the thing with the negation removed, which is P and Q. And that's going to give us a contradiction because we have a contradiction between these two. And we use that for ID. And that's what we've just done here. So when you have a derivation where one of the premises is negated, look for a contradiction with get the unnegation and use that contradiction to cancel with ID. Okay, so we'll see this strategy in some more examples in the next videos.